Hey Rails, so today's lesson is going to talk about GRASS or GRASP, which is a way of communicating our scientific understanding. So whenever we read a question, the first thing we want to do is identify what was given to us, and that's the G in GRASS. So that's our givens here. So all you need to do is just list what do we know. This might be just highlighting from the question. It might be making a list of given things in the question, like distance, displacement, velocity, time, anything along those lines. And then what we want to do is we want to identify from the question what the heck we're looking for. And that's our required. So that's the required. We're trying to list what are we looking for. Okay, the next thing is analysis. So analysis is coming up with a strategy, figuring out how am I going to solve this problem. It might be listing a sentence saying first do this, then do this, then do this. It might be listing the equation that you're going to use. There are different ways to show that you have a strategy for the question. Next, you're going to come up with a solution. This might be applying your analysis, maybe applying that equation that you came up with. And finally, in the end, you're going to have a statement. And if you are familiar with GRASP with a P on the end, it's the paraphrase. So I'm going to use a sample problem to demonstrate how we're going to apply this method of communication. In this problem, a student starts their school day 1,530.4 meters west of their house. After school, they've got guitar lessons, and they go to guitar lessons, which is at 2,046.3 meters west of their house. And what we want to do is we want to determine the distance that this student walks after school and her displacement of this walk. Okay, so let's apply our understanding to this. So the givens in this problem, I'm going to say is D1. That's their position at the start of their school day. So position is a vector, and we'll talk about that in a few lessons here. But for now, their position is 1,530.4 meters west, and that's one of the givens in the question. The other given in the question here is that at the end of their day, they go to guitar lessons, which is at 2,046.3 meters west of their house. Okay, and what we want to do is we want to determine two things. So we want to find out what delta D is, and we're looking for their displacement. So that's going to be the change in position. And we're also looking for their distance, so their change in distance. Okay, so that here is our delta D. And I've just put them down. So everything that's kind of in that aqua color is my givens. That was this. These are my givens. These are my requireds. And the next thing I'm going to do is my analysis. So my analysis, what I'm going to try to do is I'm going to try to use the idea that the change in position will be their displacement. So I'm going to draw a picture of what's happening here. So they start their day at location 1. So this is their house. And I'm going to draw the best I can do of a guitar. And there's the head of the guitar, there's the hole, and my strings. Okay, so the position 1 that they have, D1, was 1,530.4 meters, and that's west of their house. And so this is our north direction. So I'll make it straighter, north. That's our north direction, which means to the left on our page here is our west direction. So this vector here demonstrates what we have as our D1. Okay, now D2 is from their house way out to this location here. So this is what I'm going to call my position 2 of 2,046.3 meters. And again, it's towards the west. Okay, so my displacement, or the change in position that I have here, is simply going to be this piece here. Okay, so what that means is you can see that this green line and the yellow line will add up to give me kind of this light blue color. So this is my analysis here. I'm going to say that delta D plus D1 is going to be equal to D2. That's going to be my understanding. My change in my distance that I travel, so my distance that I travel, this yellow plus the green, will be equal to D2. So this is for displacement, and this is for my distance. Okay, so far all I've done is I've listed what I've known, I'm listing what I'm looking for. I've drawn a picture to try to understand what the question's looking for, and I've written down my equations that I'm going to use. Okay, so next I'm going to actually apply this. I'm going to come up with a solution. So my solution here is that I'm going to use these equations. So for displacement, again, I'm going to rewrite my equation out because that's part of my solution. It's the first step of my solution, in fact. Delta D plus D1 as a vector is equal to D2 as a vector. And let's go ahead and substitute in the values that we have. So delta D, I don't know what that is. That's what I'm looking for. But I can substitute in D1 as 1,530.4 meters, and that's towards the west, is equal to 2,046.3 meters, and that's towards the west. And I can try to isolate for delta D. So we'll do that. So to isolate for it, I'm going to subtract 1,530.4 meters west from both sides. Subtract 1,530.4 meters from both sides. And that will get me delta D is equal to, it comes up to 515.9 meters, and that's going to be in the west direction. The next thing I want to do is determine my distance. So we'll go distance. And we had an equation for distance. It was the same setup. It said delta D without the vector plus D1 is equal to D2. Delta D is, I don't know that, but I do know D1. The length of D1 is 1,530.4 meters. So it's 1,530.4 meters. And D2's length is 2,046.3 meters. And same analysis, I'm going to subtract off 1,530.4 meters from both sides. 30.4 meters. And I get a distance, and I'm just going to move this down, distance of 515.9 meters west. Now I've come up with my answers. So I have two strategies here. One strategy is that you could highlight on your page your answers, which demonstrates, hey, this is what I found. The other strategy is that you can come up and state them. So the distance that she walked was 500. Oops, I wrote down something incorrect here. I wrote down a displacement. So the distance doesn't actually have that direction associated with it. There we go, 515.9 meters, and her displacement was 515.9 meters, and that's where that west will come in. Okay, so if I look at my solution here, and I imagine it on a piece of paper, and I drop that piece of paper in the hallway, it's organized in a fashion that I'm almost certain that anyone would be able to at least be able to follow my thought process. It's all organized. As you can see, it flows down the page. It is logical left to right, and then it has a concluding statement to it. Okay, so this is what we call the GRASS method or GRASP method for scientific communication.